Hey guys, welcome back to the multiplication properties of exponents. We're going to look at some things that I think you'll find to be fairly simple. Okay, so today we're going to begin with product of powers. It's important to remember product means the answer to a multiplication problem. And what is a power? A power is when we have a number that's called the base raised to a little number that's called the exponent. That whole thing all together gives us a power. So we have the base, the exponent, and all together it makes the power. So when I'm multiplying these powers together, the commutative property tells me that I can change the order in which I multiply. So I'm going to put my 3 times 4 together, right? Because really I have 3 times 10 to the 4th times 4 times 10 to the 7th. And I'm going to put my n terms together, n to the 4th times n to the 7th. Now, we all know that 3 times 4 is 12. And what might not be apparent right off the bat is that n to the 4th times n to the 7th is n to the 11th. But let me explain why that is. Okay, so n to the 4th is n times n times n times n, right? We've got 4 of them. N to the 7th is going to be n times n times n. Pretend I wrote that out 7 times. So how many times did I multiply n by itself? Well, I did 4 times and then 7 more times, which is a total of 11 times. So that's nothing more than n to the 11th. I guess I could quit being lazy and do this. 3, 4, 5, 6, 7. And nobody wants to do that, right? What if it was n to the 100th times n to the 2000th? I'm not going to want to write it out. But I know that I can add them together, so it'd be 2,100. Okay, so pause the video and try this. Before you try it, I do want to encourage you to remember that there is an understood 1 here. If there's not an exponent, it's understood to be a 1. All right, so hopefully you did 7 times 2 times x to the first plus 4 more x's, right? Plus or times y to the second plus 3 more y's. Shoo, I don't know what's wrong with me. I can't say numbers today. So 7 times 2 is 14. X to the first times x to the 4th is nothing more than x to the 5th. Y to the second times y to the 3rd is y to the 5th. So my product is 14x to the 5th times y to the 5th. All right, so product of powers in scientific notation. I want to remind you that when we're putting a number in scientific notation, we have a number between 0 and 9. Then our decimal. We cannot have 2 numbers or it's no longer in scientific notation. And as we move, if we move our decimal place over this direction, we subtract however many tens, however many places we move it. If we move to the right, I said that backwards. If we move this direction, we subtract. And if we move to the left, then we're going to add. So hopefully you guys already knew that. That should be a review from a long time ago. But just in case you didn't, there it is. So it says the fastest recorded star in the Milky Way galaxy is the US 708, which travels 2,700,000 miles per hour. I'm going to go ahead and write that number in scientific notation. So I know the decimal has to go between the 2 and the 7. And in order to get back to this number, I'd have to times it by 10 to the 6th. I move it over 1, 2, 3, 4, 5, 6 places to the left. So I have to put a 6 up here. And of course, you can always check it. 2.7 times 10 to the 6th is 2,700,000. So this is the distance that this star travels. Okay. Now it says, how far does it travel in 1 year? Well, we know that the amount of 1 year is 8,760 hours. So again, I'm going to put that number in scientific notation. So 8.76 times 10 to the, hopefully you all said 3rd, right? Because we move it back 1, 2, 3 places. So 10 to the 3rd. So in order to find out how far it travels, well, we know that distance is equal to the rate times time. So this is the rate at which it's traveling. This is the time at which it travels. So rate times time is going to give me my total distance. So distance is equal to 2.7 times 8.76, which is 23.652. And we have times 10 to the 6th times 10 to the 3rd, so that would be times 10 to the 9th. However, It says to write our answer in scientific notation and round to the nearest tenth. We have not done this. We've got to move this over one more place. So I'm going to add another 10 here. And I need to round to the nearest tenth. So since it's 2.36, I know this 6 tells me to round that up to 2.4. So 2.4 times 10 to the 10th is our answer in scientific notation. All right, next we're going to look at a power to a power. There's a nice little song somebody made up at some point in time. It says, power to a power multiply. If it's a power to a power multiply. I don't know. Anyway, I always think of that when I say power to a power multiply. So we have a power raised to a power. So let's think about what that means. I have n to the fifth 3 times. N to the fifth times n to the fifth times n to the fifth. Again, we could write this all out. N to the fifth is n times n times n times n times n. Then again, times n times n times n times n times n. Then again, times n times n times n times n times n. Nobody wants to do that. It's easier just to say it's a power to a power. So I multiply those exponents because I have n multiplied by itself 15 times. Again, a power to a power. I multiply those exponents. 4 times 2 is 8. I encourage you to think about why this is. X to the fourth 2 times. I have x to the fourth times x to the fourth. X to the fourth times x to the fourth is x to the 8th. So this rule, this power to a power, goes hand in hand with the product of powers. This one we add the exponents. This one we multiply the exponents, but we multiply them because if I was to write this out twice, then I could add them. It works out either way you go. Okay, so 15 raised to the 1/3. So this one's kind of weird. You're probably thinking, how would I write that out? Well, we'll get into this later on in this chapter, how to write it. But if we have something to a fractional exponent, then what that means is it's going to actually be like taking the cubed root of it or the square root, depending on what this one would be the cubed root. But if it was 1/2, then it'd be the square root. But long story short, if we're just following this simple rule, power to a power multiply, well, what is 15 times 1/3? 15 times 1/3 is 5. So it's y to the 5th. All right, and last we have a power of a product. So we've got a bunch of things multiplied together, that's the product, and all of it is raised to a power. And I kind of think of this as being like the distributive property. I go ahead and put all my little exponents on there so I don't forget anything. So -3 is raised to the first power. Well, it's a power to a power, so I multiply. So -3 is now raised to the third power. X was raised to the first power. Power to a power multiply. Power to a power multiply. Okay, so now we can simplify. What is -3 times -3? That's a +9. +9 times -3 again makes -27. X to the third, y to the 15th. Pretend that's a little 15. It looks kind of big. So again, we're going to distribute that power throughout. 2 to the 5th. X to the third, all raised to the 5th, so that becomes 3 times 5, which is 15. Y to the second, all raised to the 5th, so y to the second 5 times is y to the 10th. This we can simplify. That's 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. 16 times 2 is 32. So it's 32 x to the 15th, y to the 10th. Again, you can do that on your calculator if you want to. 2, and then you hit this little caret key. I don't know if you can see this in my video. And then you raise it to the, what is it, the 5th power. And boom, it gives us the answer is 32. And that is all I have. I hope this made sense. If you have any questions, please email me and let me know. Have a great day, guys.